Alright, man, so this was the drawing that I made that I was telling you about. Now, the point of this video is just to show why we wouldn't see things tilt away if, of course, theoretically speaking, the world was round. So this here is as accurately as with my capabilities and the software I have to make a round reference of the Earth. So we have here the radius of the Earth. It's directly right in the center of the circle, and we're about, as you can see here, about 3,958.8 miles is roughly the radius of the Earth. And what I did is this line here, I copied its properties and directly cut it in half. So now this width, or this length rather, is exactly the half of this one. And then this one is exactly the half of this one. And then this one is exactly the half of this one, and so on. Just so we can get a reference point of the scale we're dealing with here on this, quote, round Earth. So we're at about 989 miles here. Then we zoom in. We're about 500 miles, represents this line. And then we zoom in further. We're about 247 miles. And then we go all the way to here, which is 30 miles, or 158,928 feet. So because now I know the ratio between the tallest building in the world, roughly, which is 2,700 feet, to this line here, I can then calculate, because I know the direct ratio between these two, I can add that same ratio to these two lines, and this here represents the tallest building in the world on this model that we're dealing with. So as you can see, a person standing 6 feet tall wouldn't even register here. So I just drew a line as close as I could here. I held down shift, so it's a nice straight perpendicular line. And this straight line represents seeing out straight. So if we were to look out straight. So as you can see, just in this image zoomed in here, it looks very flat. But as you zoom out, we're about 30 miles here. You can see that distance, stuff starting to disappear below the horizon. And I kept zooming out until, or scaling over, until the tallest building in the world was far underneath that straight view out to the horizon. So this, technically speaking, or theoretically speaking rather, in a round Earth would be completely under view. Yet, if you zoom in on it, which is what this image is here. Sorry, I don't know why. Oh, there you go. So this is a picture zoomed in on this. You can still see it looks exactly, this line almost looks exactly perpendicular to the Earth, even though it's well underneath. I mean, we're looking, what, 200 miles away, well underneath the horizon, and it still doesn't look to be tilting away at all. That's because just the size that we're dealing with, that's what we were talking about earlier. In order for a building to look like it was tilting away, it'd have to be like probably around here, which is, I mean, we're dealing with 1,000 miles away, which we'd never be able to see. So that's why we don't see, again, just theoretically speaking, if there was round, that's why we wouldn't see buildings tilting away, even though they were far away and well underneath the horizon, because as you can see here, it still looks almost exactly 90 degrees.